Lecture 4, Part 3. This topic is about humidity. Yes. So we use the ideal gas law to explain the vapor pressure. Okay. The vapor pressure is a function of the temperature. And for the dry air pressure, it comes from the wet air subtract the vapor pressure, so we got the dry air. So this is equation of dry air. And for the gas constant between wet air and dry air is based on this equation. And molecular weight of the vapor pressure divided by dry air is about 0.622. The next, if we combine the dry air pressure so we got the moist air pressure. Okay. And the next, if we divide the equation 4.1 divided by 4.3, or vapor pressure with the dry air pressure. So we can introduce one parameter we call the QV. QV is equal to .622 E over P. So QV is mean as specific humidity. So it means the mass of the can be QV is the density of the vapor divided by density of the moist air. So if the volume is cancelled, we can say that it's the mass of the mass of some vapor divided by the mass of moist air. For the gas constant is a function of the gas constant of the moist air is a function of the QV. Okay. And the next equation is equation for the saturated vapor pressure. If we know the temperature, we can estimate the saturation vapor pressure. The next, if you do differentiate of the saturation vapor pressure with time, we can get the gradients. Okay, we can use this equation later. So this curve shows the relationship between temperature and vapor pressure. This should be from this equation to plot the curve. Is that exponential function? Okay, the next parameter we call the relative humidity. Is the vapor pressure divided by saturated vapor pressure, and we can estimate the saturation vapor pressure using the dew point temperature to estimate E. Okay, give the next example, how to use the climatic data to estimate the vapor pressure, relative humidity, specific humidity, and air density. Okay, given the air temperature, we can use this exponential function to estimate the saturated vapor pressure. So in this case, it means exp is mean 611 e power in the bracket. If we divided time and divided, we got this number. So it means exponential, this is e power bracket. We can have to identify parameter and number. First, P, the pressure of the air is 100 kilopascal, and temperature of the air is 20 degrees C, and dew point temperature is 16. I want to find vapor pressure, relative humidity, specific humidity, and air density. Okay, so we got the first solution. The first solution is from we have to use the dew point. This dew point temperature 16, and we can estimate vapor pressure. That's the first solution. We have 1819 Pascal. Okay, the second answer is relative humidity. So E divided by E sub S, we got the relative humidity. And the third answer from specific humidity, we use the vapor pressure divided by P. So we got 0.0113 kilogram per kilogram. And this one we can estimate the gas constant for the moist air. 289 and estimate the temperature on Kelvin 293 degree Kelvin, and we can estimate the density of the air. About 1.18 kilogram per cubic meter.